Okay, so now we have already learned a lot about the short run cost curve and how it relates to production. So what we did is we looked at the production function where we convert input into output, and we could see that initially output grows faster than input. So we see here the curve which is increasing at an increasing rate, and then we reach a point of inflection, and then eventually output only increases at diminishing rates, and from that we derived the marginal cost, which is basically the slope on every point of the curve, and we can see how that gets steeper and steeper, but then after the inflection point becomes again flatter. So we have after the inflection point decreasing returns to scale, and then we derive the marginal cost function, which has its maximum at the point of inflection. We also derived the average total, the average product of labor, and we have seen that this one has a maximum when we go from the origin and we try to find the biggest slope that still touches the production function. So this gives us the average product, and that one was this line here, and we can see it has the maximum where it intersects the marginal. Then we moved to the cost function. When it comes to the cost function, we have now output on the x-axis and total cost on the y-axis, and so here we have fixed cost, then on top of it we have the total variable cost, and you can see that it increases first at the decreasing rate, and then there's also a point of inflection, and then it increases at an increasing rate. Then we derived again the marginal cost, which is the slope mathematically at every point, and we can see how it starts out steep and then becomes flatter and flatter. There's again a point of inflection, and then the marginal cost increase faster than the output. So that was the marginal cost function. That's a very important function that we still work with a lot and which we need to understand better. So here we have our marginal cost function. Then we looked at average total cost, and then we used again this trick for the average variable cost to find the minimum, which is here. So average variable cost is always total variable cost over Q. So the average variable cost, let's make that in green, is this curve here, minimum. And last but not least, when we calculate the average total cost and we try to find the minimum, then we can find that maybe here. So this will become now an important curve for later. So, but in summary, what we have shown is that the minimum of average variable cost intersects with the marginal cost. I will not go over that proof anymore. Likewise, the minimum of average total cost intersects with the marginal cost. So those are basically these points here. So the minimum of ATC and the minimum of AVC, as we have seen, intersect with the marginal cost, and we also have seen that the maximum average product of labor intersects with the marginal product. And last but not least, we have seen that whenever the average labor product is in its maximum, average variable cost is in its minimum, and whenever the marginal labor product is in its maximum, the marginal cost is in its minimum. Okay, so that is a short run. And again, the short run is or assumes that we have fixed capital. In the long run, we assume we can change our capital endowment. So, but then what will we do? So in the long run, we assume that we can choose between different capital endowments or plan sizes. And earlier I used that example of a kitchen. So let's say currently I live in a place where I have a kitchen, but if I move to another place, maybe I want to choose a bigger apartment or a bigger house, I can choose a bigger kitchen, which is the equivalent to a bigger plan size. And then if I have a bigger plan size, a bigger kitchen, maybe I can realize more specialization gains, and I can maybe produce at lower average total cost. So what you see here is basically 3 plan sizes. Like there's a plan size which is relatively small, and that has the minimum of average total cost maybe here. But then I have another one, maybe there's another plan size which is a bigger, think of it as a bigger factory. I can realize in the bigger factory more economies of scale and specialization gains, so I can produce a certain good with lower average total cost in the minimum. And I can also imagine that I have a super large plan size where we have one factory for the entire company, for the country. So that would be like the case of the socialist economies, where they had literally very often one factory producing everything for the entire country. But now probably average total cost, or the minimum of average total cost, goes up again. So what this tells you is that if we choose between different plan sizes, bigger does not always mean better or allowing for lower average total cost. And again, the example with maybe socialist economies like the former Soviet Union, that might be insightful, because we have to think in terms of 2 costs also. So when we increase the plan size, so if we increase maybe the plan size, then, and you think that, organizing a plant has organizational cost and planning cost. So we can call that maybe planning cost, or planning cost. Well, and those planning costs, they are likely to go up with the plant size. So imagine if you have one factory that is supposed to provide everything for an entire nation. Well, the bigger it is, the more planning is necessary. But then again, on the other hand, if the planning goes well, maybe the average total cost, so ATC, they actually may go down. So could be that they actually go down, but they also may go up again. But so what we need to do is we can think of the optimum plan size as two costs, planning cost and the average total cost, which are the result of the plan size. But then if we aggregate that, if we aggregate vertically the two costs, we can see there must be some optimum plan size. And this is a different view on the same concept. So now, if we take a look at all the possible plan sizes and we look at the average total cost function associated with every plan size, then we can wrap around the curve, which is known as the envelope, that captures all possible average total costs associated with every plan size. And so this is this envelope here, the dashed line. So that essentially takes a look at all possible plan sizes, and then of course we try to identify the optimum plan size, which would be here, the green one. So that is the optimum plan size, and that will play a role later when we talk about perfect competition, because one of the most beautiful things of perfect competition is that it will allow people to, or it will allow companies to adopt over time the optimum plan size. But let's talk about that more as we move to perfect competition from a separate perspective.